Hello, folks. Good morning. Thank you so much for being here. I'm super excited and honored to be part of first ever PyCon Africa, and kudos to all of you and the organizers for doing this. Am I audible everywhere? Is the mic working? No? It is working.
It sounds like
Hello.
it's working.
Yeah. So I'm Sherin Thomas, and I'm going to talk about Hangar, PyTorch, and RedisAI. Don't worry about this new terminologies that you're listening today, because I'm going to take you through each of this and trying to make you understand why or what a deep learning workflow is and why is that important. Before jumping in, I want to understand the audience. How many of you guys are not Python developers? Never used Python before? Nobody? Very minimal Python knowledge, very basic. No? 1, 2, 3, don't be shy, that's okay. 4, 5, oh wow. Okay, it's 20% of the audience. Cool. How many of you guys are not, or never done any deep learning stuff so far? Anything in deep learning? Never done? Okay. So for the people who have used or did something in deep learning, have you guys done traditional ML or TensorFlow DL or PyTorch DL or some other frameworks? Hands for those who have done traditional ML, only traditional ML. Okay. TensorFlow? PyTorch? 3. Okay, cool. So you have listened to one talk previously, which was, or almost all the talk that you're going to listen to in the real world about deep learning is how you build a deep learning model and how you can train it, how you can run through a loop and train your network and build layers of your network. But almost always you don't get to listen to the whole deep learning workflow, which is what you actually need to implement something from scratch. If you have an idea, how you can take that to a process where you can deploy that to production. So the talk I'm going to cover is through all those process, but not probably covering every aspect of it because of the time limitation. And the code is, the whole slide is sort of code intensive. So if you are lost somewhere, I'm happy to host a 30 minutes session after the lunch or something if there's a group of people who want to actually run the code or want me to explain the code and run you through it. It's not working? Okay. Sorry. Okay, I'll probably use the. Okay, now it's working, cool. So yeah, this is me. I'm HH2nd, HHSECOND everywhere, Twitter, GitHub, LinkedIn. So as part of the community service, we are doing college training of deep learning / Python, and part of that, we are planning to start by next month a deep learning weekly tips, which will be sent through my Twitter account and through turingnetwork.ai/tips. So if you are new to deep learning and if you want to learn tips that could take you further, you can watch my Twitter handle. So we're going to be planning to start by starting of September. So I work at TensorWork, which is a super early stage startup. Me and my CEO is from Italy, my CTO is from New York. So we're just 3 people working on a couple of toolkits that we think are relevant to the community. So all these ideas came from the frustration that we had when we were doing deep learning for work. So I created turingnetwork.ai. Again, that's an exploration tool. It's not for public use yet. I'm trying to find resources who could help me out with pushing it further. I co-organized Deep Learning Bangalore, which is one of the most effective and popular deep learning meetup in Bangalore. Yeah, so that's about me. Before going to the whole idea of deep learning workflow, I want to to introduce you to Software 2.0. Has anybody heard this term, Software 2.0? No? Okay, awesome. So anyone know Andrej Karpathy, Director of AI Tesla? No? Has anyone done CS231N from Stanford, the course? It's available in YouTube. Okay, so before jumping in, if you are a deep learning, if you want to be a deep learning engineer, it's a good start to go to CS231N. You can YouTube it. You get like a bunch of videos, around 21 videos. It's actually started. The video streaming was started by Andrej Karpathy. He's the director of AI at Tesla. So he defined the term Software 2.0. I'm not sure whether there were any other attempts to do that before. So Software 2.0, as per definition, is basically what we had is Software 1.0. The components of Software 1.0 is here. Right, you have source code, compiler, executables, a virtual machine maybe, test cases. Software 2.0 says this is going to be replaced by a couple of other things, the alternatives, and which is probably or fundamentally driven by data, right? So the source code is going to be replaced by data because earlier you used to write conditions, for loops, etc. But now it's going to be changed by decision that's been made by the data through training process, right? So that's the idea. So all of these components has an alternative. It's like a very long blog post made by him. You should check it out. Software 2.0. Google it. You should be able to find it. So Software 2.0, which is what we call as the AI first world, does not have enough tools or the tools required you to build Software 2.0, right? So could you guys imagine if you did not have GitHub and you programming, right? Now it's not possible for us to imagine because that's so part of our daily workflow when you do Software 1.0. So similar to that, there's a bunch of toolkits like Jenkins, Ansible, like a bunch of toolkits that is helping you to build software in 1.0 world. But do you have anything to do that in Software 2.0? So I'm referring to the talk Mustafa has given yesterday. You have certain toolkits available, use those. We do have certain toolkits available, but we don't have all the toolkits required for doing Software 2.0 when you move from Software 1.0 to 2.0. So TensorWorks exists to, like I said, through the frustrations that we had while we developing Software 2.0 with the tools that we had for Software 1.0. And a typical example that I could give is, where do you save your data, right? So all this deep learning, machine learning stuff starts where? You collect the data, you have a lot of data, then you clean that data, then you use that data to train a network that you have built, correct? Everyone agrees? Okay, so where do you keep this data? Where do we keep source code? Some version controlling, right? So that we know we're not missing it. So if you don't understand what I'm saying, raise your hands. I'm super happy to explain it again. So what we did was we put this data into Git LFS that stores bigger files like blobs. So putting image to Git is not really ideal. So we try to use the existing toolkits, which is developed for Software 1.0, but that never worked out. So similar to that, there were other frustration points that led us to build TensorWorks, and the toolkits that we are building is basically for handling such issues. This is the suite that we are developing. Hangar is the version controlling that I'm talking about. Then there's Suppression, which is an AI auditing tool. Then Substrat, a CI/CD automation. So if you have used Jenkins or Ansible, you probably have to replace that with something like Substrat. Then RedisAI is for deploying your model to production. So I'm not going to talk about Pression and Substrat because it doesn't exist. It is just basically theoretically in our mind that we know that we will build this in some point in time. But we have built Hangar and RedisAI already. And I'm going to run you through how to store data in Hangar, how you can take that to a world of deep learning model training through PyTorch. Then from there, how you can, once you have a trained model, how you can take that from, So okay, so give me some examples. So if you have a deep learning model that you trained, right? You have trained a deep learning model, and you have like 99.9% accuracy. What do you do next? Right? You have a model, you have trained it. What do you do next? You have a model, let's say you made to help farmers, right? You have a bunch of farmers to identify the disease or something. You made a model. What do you do next? Where will you take it next?
Wrap it with an API.
Right. Wrap it with an API. Anything else?
Wrap it with a mobile app.
Build a mobile app. TensorFlow serving. Cool. So we have like two options now. Wrap it with an API, probably Flask or Django or something. Then TensorFlow serving. Cool. We have two choices. OK, good. Let's say you are building up a company and you're scaling now. You're scaling to 10,000 users requests per second. Do you think you can scale TF serving to that level without introducing a new toolkit? No, you can't. You have to introduce Kubernetes or something similar. Do you think you can scale API, which is written in Flask or Django? No, you can't. You have to introduce some new toolkits. Now you are in need of hiring a new person who could help you out with scaling it up, right? With some other toolkits, which you probably don't know already, right? Or you have to put your ass online and learn it, and then take it. So these are the fundamental problems that you're going to have. So RedisAI we built RedisAI along with, in collaboration with Redis Labs. OK, before going there, how many of you don't know Redis? What Redis is? OK, again, like 10% of the crowd. So Redis is a database, in-memory database, that can store data in the memory. And OK, I have a slide about that. We'll go there when we reach there. OK, so this is a typical deep learning workflow that I have defined. I don't know whether this is what everyone uses. So the whole process starts from the ideation and planning phase. This is probably similar to Agile if you have worked with Agile, but not exactly Agile. So you have an ideation and planning phase. That's like you have got an idea to build something. You have an idea in your mind, and you are trying to ideate or brainstorm with your friends what you could do next. Then you move to design and experimentation phase. You collect a bit of data. You try to build a small model. You try to use an existing model available already. You train it. You see whether you are getting some good result. Then you go to the model implementation phase, where you probably create a new model, a new architecture itself, and then you try to use the same small data set to understand where your accuracies are. Then you move to training and validation. You have decided what your model should be. You have enough data. You implement the model. Then you train it and then validate it. Now you have a trained, super accurate model. You take it to production. Along with all these phases, there's a parallel phase running, which has a couple of things to do. One is data collection, data storage. Another is unit testing, and et cetera, right? OK, so in this graph, in this flowchart, what you already know with TensorFlow or PyTorch or scikit-learn or Spark or whatever is probably going to be in that design and experimentation, model implementation, and training and validation phase. So, right, these three phases are going to be covered by what you already know or what you're aspiring to learn. So when somebody say, I want to be a deep learning engineer, this is what you are probably, in your mind, this is what you probably want to do, covering these three phases. But what's next and what's before, right? You need data to go through these three phases. Once you have the model trained, you have to take it further, right? What do you do there? So we're starting with Hangar. Hangar is Git for data, basically. It has all the features Git provided us a couple of years back to build software 1.0. You can branch. You can create new branches. You can merge branches. You can time travel through the history. You can go back to an older commit and see what was the data. Clone, fetch, and push. You can clone the data. You can fetch, push. So basically, whatever you could do with Git, you can do here, right? What is a necessity? Why do you need that? So almost always, what are you going to do with, especially when you learn, right? Like in the previous speaker said, you probably go to Kaggle, download the data, then build a model, right? But that's not how real world work. You are going to get the data from the real world, probably every week, every day, every second, I don't know. So you have some way to store this data and some way to look at this data and say, the data that came this week has reduced the performance of my model. The data has came last week has increased the performance of my model, right? So you have some way to do that. You need some way to do that. So with the existing tools that you have, it's extremely difficult, and the difficulty escalates if you have more than one source where you get the data from. Let's say you have 5 people working in 5 universities to collect the data, correct? 5 people are uploading the data to some common storage that you have, and one fine day you realized your model is not performing well, right? And that's probably not because of the data from 5 sources, probably because of one source. Do you have any way to know that? No, you just push the data to a folder, and you don't know who pushed the data unless you keep a track of it. So, okay, another problem that you might be facing, especially when downloading data from Kaggle. So, I was training a semantic segmentation model where you can segment the objects in a frame, and the data set was 3 TB, right? So and I was trying it out. In the early stage of my career, I was trying it out. I was trying to learn deep learning. So just to learn, I have to download 3 TB of data, which I'm not sure is going to help me. That's crazy, right? I probably don't need 3 TB of data. So with Hangar, the way we try to avoid that problem is, you can partial clone. You can say, Hangar, dude, I need like 200 MB of data. So Hangar take the first 200 MB of data and give it to you, so that you don't have to.
Randomization?
Sorry?
With the option of randomization, maybe I tell Hangar, bring me a random 200.
You can tell Hangar to do that, a random download, or like first, yeah, whatever. Yeah, you can do that. Okay. So data interaction, you have like a powerful CI. So if you have like a folder full of data, you can do Hangar import that folder full of data. That's going to get you the data. And it has a powerful API because the data in Hangar are NumPy arrays. So you can directly, so if the data is an image, what you have to do is go through a pre-processing step where you read the image and make it as a tensor, then run through the model. But with Hangar, you don't have to do that because the data is already tensor. When you do Hangar import, you get the tensor version of that image or whatever. Then use the Python API to load. Can we take the questions? Because I, okay. Were you trying to ask a question?
I was asking, all the data are tensors already
right.
In the Hangar.
Right.
They are tensors.
Right. So you can pull the data from Hangar while you run the model without doing pre-processing, which is cool. So these are the command line options that you have. You have branch, clone, all the options. 2 particular things that I want you to really careful about, or like really excited about, is export and import. So you can export, like I said, you can Hangar import folder full of images. Hangar make sure that is being converted to tensor. Hangar export one image. That'll make sure you are exporting one image. So this is a Python API. You import Hangar, import repository. Then you have like all the operation that you have in GitHub. Report or checkout. You can diff. You can see the difference between 2 branches. You can make torch dataset. We'll create a torch dataset with your data. Then you can use that for training your network. Hangar is 0.1.1 now. We are pushing 0.2 release today or tomorrow, with a lot of. So most of the good features that I've taught today is going to be there tomorrow. So I was trying to push it before I came here, but I was planning to work on flight, but never happens. Sorry about that. So you could get that tomorrow. What we really need from you is a star there. If you are interested in Hangar, if you think this is going to help you in some way, and if you like the project, please go there, give us a star. Next is PyTorch. I don't have a lot of time, like 5 minutes more. That's sad. Okay, so the only 3 things that I'm going to introduce you to is torch.dataLoader, data.dataloader, torch.nn, the whole package of pre-built layers for you, then torch.optim that has the optimizers. So this is a simple script that I have. Make torch dataset, the same function that we have seen in the previous slide here. So make torch dataset, you import that from Hangar. Then you can pass the Hangar dataset to create a torch dataset. Then you can, this is a model that I have, like I have a sequential model. So making a model in PyTorch is extremely easy because almost all the models that you need is already available. Sequential, linear, ReLU, so all this, you stack this together, you have the model ready, you have the loss ready, you have the optimizer ready. Then you build a dynamic graph. This is where things get different from TensorFlow to PyTorch. So if you are a new person to deep learning world, I would encourage you to go and check out PyTorch instead of starting with TensorFlow, because PyTorch is extremely easy and beginner friendly. And once you know the basics of PyTorch, you probably can move to TensorFlow for production deployments and stuff. But start with PyTorch. Okay. So once you have the PyTorch model, you have trained it. This is the training loop. You trained it. Then you convert that to an optimized version by doing torch.git.trace. So there is a new version of Torch released yesterday that has a much better version of, much better API to do this, conversion. So like you have a model which is trained, which is in the Python scope. Now you have to serialize that to disk, and then load that to a production runtime. So you can use this to you create a trace graph or a scripted graph, then graph.save, you can save it to the disk. RedisAI. Okay, so this is where the question, this is where the question comes. Okay. What are the production strategies? The question I have asked, different approaches, but none of these are standard. None of these are efficient enough to handle all the requirements that you have. Okay, so for answering your question about Redis, for those who doesn't know what Redis is, Redis was top on the developers' favorite database in last 3 consecutive years by Stack Overflow survey. So that is the the range of, or the size of the community that uses Redis. So Redis is so popular because of several reasons. It's extremely fast. It can scale to a million billion requests per second without you doing a lot of work. You just have to plug different nodes to this and say, this is my cluster, do whatever you want. Redis automatically scales and makes sure your server doesn't go down. So we use Redis. The reason why we use Redis is because of all these cool features Redis has. So what we do with Redis is we took TensorFlow's backend, PyTorch backend, and ONNX runtime, which is made by Microsoft, these 3 backends, and plugged that to Redis. So now Redis is not just a database. With RedisAI, Redis can run your deep learning model inside the database, right? Since Redis is a database, you can store the data in Redis, and you can run your model inside where your data lives, which will save you, millions in cost if you have like a lot of requests that's happening. This is RedisAI GitHub. So both of the products and PyTorch, all 3 are open source. Feel free to contribute. Feel free to raise issues if you have any. Again, we really appreciate if you can give us a star.
Restate what you just said. So I set up a Redis cluster. So I said Redis, a normal Redis distribution. I use this RedisAI one.
So RedisAI is not another Redis. You plug that into your existing Redis. Yeah, it's a module. So I have an example.
Existing cluster.
You can do that.
I can run TensorFlow
Right.
inside that cluster.
Right. Exactly. So Redis has TensorFlow, PyTorch, and ONNX, and basically all this, like scikit-learn, Spark, all of this, the models built in those framework can be converted to ONNX. So we have made a package called ML2RT. ML2RT is a package that can help you convert your model to ONNX and then deploy it through Redis AI. So this is steps. So if you have set up Kubernetes, you know how difficult it could be to understand the internals. But this is the only thing that you have to know, like, 20 lines or like 15 lines of shell commands. So first set, 6-7 line is how to install Redis. So once you have Redis, you install RedisAI. That's like another 6-7 lines. Then this is the last line. So redis-server is the command that you give to bring up a Redis server. But along with that, if you pass load module build RedisAI SO, it's a shared object. So once you do that, your RedisAI server is up and running without you do much of a hassle. So this is the architecture of Redis. It can run on CPU, it can run on GPU, it can run on TPU. We are trying to integrate couple more backends. So RedisAI Redis never, so people who know Redis already, Redis never had a data type tensor. With RedisAI, we had introduced Redis tensor as a data type, and then those backends for running the model. So this is a typical architecture. You have something called script, which I'm not covering today. You deploy the models there. You can run the whole process, and the process is going to look like this. So this is Redis ecosystem where, like one of the particular, a good feature of Redis. So this is your typical setup where you have 4 machines with 1 master and 3 slaves. And let's say your master went down, right? Your master had gone down. Can everyone listen to me? I mean, am I audible? Oh, cool. So your master gone down. So in a typical scenario, unless you have Kubernetes, the DevOps engineer in the midnight taking a call saying the master things are not working, he goes down and bring it up, right? But what Redis could do is, there's something called Redis Sentinel. What Redis Sentinel could do is it automatically elects something else, one other node as master, and bring up the all infra without you worrying about anything. So like users would never know anything going down, and you would probably get an alert saying, dude, your machine had gone down, bring up that machine which is down. Advantages, not going there. This is a Python example. There's a package. So that's ML2RT, the converter that I was talking about, then RedisAI, then these are. So I've written a blog post that explaining RedisAI. You can go through it and try to understand how does it work. Yep, so I'm done. I'm super hopeful about your feedbacks. And if you have ideas that you want to contribute, go ahead to GitHub, create an issue. Somebody would definitely reply to you. So like I said, we 3 people are working from 3 time zones, so you'll get support 24/7. Some of us will answer for sure. GitHub stars, of course, yeah. Thank you so much for having me. It's a great pleasure.